Yeah, good morning all. Now we will discuss some more problems on stability. Okay, see here characteristic equation is given. Characteristic equation, that is nothing but 1 plus g of s into h of s value is s power 4 plus s cube minus s minus s square minus s. Okay, determine the number of left hand poles and right hand poles. That means here we don't need to find out the stability. Why? Because here negative coefficient means that the given system is unstable system. Negative sign is there, right? Next, s power 4 s cube s square s power 1 s power 0, right? S power 4 coefficient value is 1, s square coefficient value is minus 1, right? Next, constant, no constant, right? 0. Next, s cube coefficient value is 1, s coefficient value is minus 1, right? Next, 1 into minus 1, minus 1 minus 1 into 1, you will get plus 1, minus 1 plus 1, you will get 0 by 1, that value will be 0. After that, 1 into 0, right? 1 into 0 minus 0 into 1, that means here this row value will be 0. Okay, see here, if any one row becomes 0, then we can consider auxiliary equation by considering above row power terms, right? That means this value is 0, right? S power 2 term row is 0. When s power 2 row term is 0, then we need to consider this s cube row. Okay, that means this is s cube term, right? This is s power 1 term, right? Now auxiliary equation is equals to s cube. This is s cube, right? Minus s. Okay, after that, differentiate this auxiliary equation. Differentiate this auxiliary equation with respect to s. What is the value? 3s square minus 1, right? Now here this s square coefficient, first s square coefficient, right? First this s square coefficient is replaced by this constant coefficient. Next, this constant coefficient, this 0 is replaced by this constant coefficient. Okay, 3 and minus 1. Okay, now see here, again from this equation, 3 into minus 1, again we need to proceed RH criteria. 3 into minus 1 minus 3 minus 1 into 1, minus of minus plus 1, right? Okay, minus 3 plus 1, you will get minus 2 by 3. Okay, next, 3 into 0, 0, right? Minus of minus plus 1. Okay, 1 by 3. Next, minus 2 by 3, minus into minus plus, right? Plus 2 by 3, plus 2 by 3, minus 1 by 3 into 3, you will get 1. Okay, that means 2 by 3, right? 2 by 3, again here minus 1 divided by minus 2 by 3, right? That is, yes, see here, just observe here, 3 into 0, 0, here also 0, right? 0 into 1, that means 0 into 3 into 0, 0, minus 0 into 1, 0 divided by 3, you will get here 0, right? This value is 0. Okay, please observe clearly. Okay, after that, next, minus 2 by 3 into minus 1. Okay, minus 2 by 3 into minus 1, you will get plus 2 by 3 minus 0 divided by minus 2 by 3. 2 by 3, 2 by 3 and cancel, you will get minus 1. Okay, for this type of problem, first you need to consider auxiliary equation roots. Okay, that means, see here, this auxiliary equation starts from s power 2 term, right? Below auxiliary equation, number of roots is equals to, how many roots are there? 2, right? S square term means number of roots present is 2. Okay, now see here, below the auxiliary equation, how many sign changes are there? From s power 2 to s power 1, plus 2 minus 1 sign change. Again this is also minus only, right? That means only one sign change. That means number of right hand poles is equals to 1. Okay, in case of auxiliary equation, okay, remember this point, in case of auxiliary equation, number of right hand poles is equals to number of left hand poles. Okay, that means number of right hand poles already calculated right from this equation 1. Then number of right hand poles is equals to number of left hand poles, right? Number of roots is equals to 2, right hand poles is equals to 1, left hand poles 2 is equals to 1 plus 1 is satisfied, right? Then roots on j omega axis 0 is 0. This is clear, right? After that, number of sign changes in characteristic equation, right? Again only one sign change, right? That is also here only. That means number of right hand poles is equals to 1, j omega poles from the previous expression 0, then number of left hand poles is equals to 3. Okay, in this way we can solve the problem when any one row becomes 0. Next problem, s power 6 plus 3s power 5 plus 4s power 4 plus 6x cube plus 5s square plus 3s plus 2 is equals to 0. Okay, already this problem is solved. Just clearly observe here. First, s power 6 term coefficient is 1, s power 4 is 4, s square is 5, constant is 2. Next, s power 5 is 3, s cube is 6, s is 3, right? Okay, next, s power 4 term, 3 into 4, 12 minus 6, right? That is 6 divided by 3, you will get 2, 3 minus 5, 15, minus 3 into 1, 3, 15 minus 3, 12, 12 by 3, you will get 4. Next, 3 2s are 6, minus 0 divided by 3, you will get 2, right? After that, 2 6 are 12, minus 4 3s are 12, right? 12 minus 12 by 2, that value is 0. 2 into 3, 6 minus 2 into 3, 6 minus 6, again this value is 0. 2 into 0, 0 into 3, that value is also 0, right? This row will be 0, right? Then auxiliary equation 1 is having, consider the above value, 2s power 4 plus 4s square plus 2 is equals to 0. Differentiate this auxiliary equation 1, you will get 4 into 2, 8s cube plus 4 into 2 into 4, 8, yes, right? After that, 8 and 8, right? Here these two zeros will be represented by 8, replaced by 8 and 8, right? Next, continue the RH criteria. 8 into 4, 32 minus 8 into 2, 16, right? 32 minus 16, 16 divided by 8, you will get 2. Again 8 into 2, 16 minus 0 by 8, you will get again 2, right? After that, 2 into 8, 16 minus 2 into 8, 16, 0, right? 2 into 0, 0, 0 into 8, 0, that value is also 0, right? That means here 2 times row elements will be 0, right? That means when 2 times of row elements are 0 means then the given system is blindly, you can follow unstable system. Okay, if auxiliary equation is 2 times are repeated, then the given system is unstable system. Okay, next, last model in the stability analysis. Okay, find the range of k for stability. What is given? G of s is given, k by s into s plus 2 into s plus 4 into s plus 6. We need to calculate k value, right? Okay, system is marginally stable. Remember this point, system is marginally stable. First, g of s is given, right? Assume the given feedback is h of s is equals to 1. Then the characteristic equation will be 1 plus g of s into h of s. Okay, that is 1 plus k by s into s plus 2 into s plus 4 into s plus 6 is equals to 0. Okay, na 1 plus k by s into s plus 2 into s plus 4 into s plus 6 is equals to 0. Okay, if I simplify that equation, I will get a characteristic equation as s power 4 plus 12s cube plus 44 s square plus 48s plus k is equals to 0, right? Then again here I need to use again RH criteria, s power 4, s cube, s square, s power 1, s power 0, right? That is 144 k. Next, 12 48, right? Next, in case of s square term, 12 into 44 minus 48 divided by 12. If I simplify this equation, I will get 40. Next, 12 into k minus 0 by 12, I will get k. Next, after that, 40 into 48, that is 1920 minus 12k divided by 40. Next, 40 into 0, minus 0 into 12 divided by 40, that value will be 0. After that k. Okay, for stability k greater than 0. Okay, that means here it is given marginally stable, right? That means 1920 minus 12k by 40 is equals to 0. If we simplify this equation, we will get k value. Okay, after that, suppose if we ask what is the frequency, that means first to find out k value we need to equal s power 1 rho is equals to 0. To find out system frequency, what is this equation? 40 s square from s power 2. From this equation 40 s square plus k is equals to 0, right? Okay, that is 40 s square is equals to minus k, right? Then s square is equals to minus k by 40. Okay, then you will get s value. From this equation you will get s value. Okay, in this way we can calculate k value as well as s. S is nothing but in place of s you can substitute j omega. Then here also you can get frequency omega in radians per second. Okay, thank you all.